All right, so in this video, we are going to continue on in chapter 2, I guess I should say, and do section 2.2. We're going to talk about the derivatives of exponential functions, more specifically the base E functions. In the last video, we went over a lot of the algebra review stuff that I wanted to cover from a college algebra class. This is going to be more of the calculus base behind this. So the good news is that when it comes to the derivatives of exponential functions with base E, there's really only two rules you're going to have to know, and one of them is not really any work at all. So here's the two rules. If you take the derivative of a function defined by just e to the x, this is one of the easier derivatives that you will take in this class. The derivative of e to the x is going to always just be itself. It doesn't change at all. So the derivative of e to the x is just e to the x. Where you have to do a little bit of work is when the power of e is something other than x. So if you were asked to take the derivative of e raised to a function of x that's not x, so like if it was e to the x squared, this rule would apply down here. To take the derivative of e raised to f of x, you will take the derivative of the power, which is f prime, and that will come to the front. Your e function doesn't change at all. Now, I know it's going to be really tempting to subtract 1 from the power because you did that in the power rule. But with e's, you don't touch the exponential function. All you have to do is multiply it by the derivative of the power. So those are the two rules we're going to practice in this video. So we're comfortable taking derivatives of e when it comes to exponential functions. All right, so here's numbers 1 through 3. All I want you to do is practice, and we're going to find the derivative of the following functions. So for number 1, g of x is equal to e raised to the 3x. So remember, the rule that we're doing over here on the right is if you take the derivative of e raised to a function, this will just be f prime of x times the original exponential function. So you have e to the 3x. So if you want to find the derivative of this function, first thing you do, it's e, you take the derivative of the power. So the derivative of this 3x is just 3, and you write that down. Then you just bring down the original exponential function. So your final answer will be 3e to the 3x. So that is g prime of x. All right. For number 2, if f of x is 2 times e raised to the 5x plus 1, find the derivative the same way. The only difference in this one is that you have a constant in the front, but we've talked about how to deal with that in previous sections. So for f prime of x, first thing you do is you take the derivative of your power. So the derivative of 5x plus 1 is 5. Now, it comes to the front, but since there is a 2 already there, just like in the power rule, you go ahead and multiply those together. So the derivative of this is 5, and therefore 5 times 2 is 10. Then the e, you just bring down. So that is e to the 5x plus 1. This is the derivative of your function. Nice and simple, right? Any power of e, the same rule applies. So if you want to find the derivative of, let's say, y equals e to the x cubed, so y prime would be take the derivative of your power. So the derivative of x cubed is 3x squared, and then just bring your e down, e to the x cubed. That is y prime. And that's about the extent of what derivatives of e's are going to be. Now, there are different variations we're going to run through in just a second, but I wanted to get the main idea down on this slide because that is the building blocks for the rest of these last few slides. All right, let's do a couple more. Number 4 is just kind of starting to combine rules here. So what if f of x is x to the 5th minus 2e to the 6x? So when you go to find the derivative of this function, since it's just being subtracted, you take the derivative separately. So first off, the derivative of x to the 5th is just a power rule. So that would be 5x to the 4th minus, here's that e derivative again, So remember, you take the derivative of your power, which is 6x. The derivative of that is 6. When you bring it to the front, that 2 is already there, so you multiply them together. The derivative, which is 6, times this 2 would give you 12, and then you bring down your e, which is e to the 6x. That is your derivative of this function. Just like any other section, we're going to run into more square roots. So on number 5, you can't take the derivative of this just yet. You will have to rewrite it before applying one of your rules. So if g of x is equal to the square root of e to the x plus 7, this can be rewritten, as we've seen numerous times now, as e to the x plus 7 raised to the 1/2 power. Now, if you look, this looks more like the chain rule that we covered back in section 1.7. So we have to apply our chain rule idea in order to get the correct derivative. So g prime of x is going to be, so let's review the chain rule. Chain rule says you bring the power to the front, which is 1/2. You leave the inside function alone, which is e to the x plus 7. Subtract 1 from the power, which makes it negative 1/2, and then you multiply by the derivative of the inside. Well, the derivative of e to the x is just e to the x, as I showed y'all earlier, and the derivative of 7 goes to 0. Just like the other chain rule problems we did, you'll multiply the two terms that are not being raised to a power. So 1/2 times e to the x is just e to the x over 2. And then you're going to multiply by e to the x plus 7 raised to the negative 1/2. And that is the derivative of number 5. All right, so I showed y'all a chain rule example. Don't forget that also in section 1.6, we covered product and quotient rule. So you have to remember those derivative rules as well when it comes to e's. For example, number 6, we want to find the derivative of x to the 7th times e raised to the 4x. As you hopefully notice here, you've got two different functions with x's that are being multiplied together. So you're going to have to do the product rule, like I said, back from section 1.6. I'm going to let x to the 7th be my f function, and I'm going to let e to the 4x be my g function. My product rule says that we are going to do f times g prime plus g times f prime. So when I apply this formula to the derivative of my function, we should get the following. F prime of x will be f, which is x to the 7th, times the derivative of g. So that's your exponential rule. Take the derivative of your power, which would be 4, and bring that to the front. And then you have e to the 4x. Plus your g function, which is e to the 4x, multiplied by the derivative of f, which would be 7x to the 6th. If I clean this up a little bit to make things look a little nicer, this would be 4x to the 7th, e to the 4x. So I just kind of rearrange the terms there. And then I'm going to bring this term to the front and make it plus 7x to the 6, e to the 4x. So this would be an acceptable answer. Now, something we might have to do a little bit later is factor this. So if you'll notice, there is a couple of things in common with both of these terms. They both share an x to the 6th in common, and they both share the exponential function in common. So I can factor out x to the 6 times e to the 4x. Inside parentheses, if I write down what's left over, looks like there's going to be a 4 and 1x left over here, and then plus, and the only thing I didn't factor out here was the 7. So if you wanted to go for a more factored form, which we will need later, we could write it as x to the 6 times e to the 4x multiplied by 4x plus 7. So there's your product rule example. We can also do the same rules with quotient rule. So let me show you an example of that. Number 7. What is the derivative of e to the 3x divided by x to the 5th? So this time, as you can see, we have one function with x's on top, and we have one function on the bottom with x's, so we're going to apply the quotient rule. If I let the top be my f function and the bottom be my g function, I can define the quotient rule as g times f prime minus f times g prime, all divided by g squared. So if I go through this formula and take my derivative, so f prime of x will be my g function, which is x to the fifth, times the derivative of f, which would be 3e to the 3x, minus f, which is e to the 3x, times the derivative of g, which is 5x to the fourth, all divided by g squared. So x to the fifth, all squared. If I clean this up, so rearrange some terms here, you're going to have 3x to the fifth e to the 3x minus 5x to the fourth e to the 3x, all divided by x to the 10th. Now, if you notice, we saw this back in the chain rule section. There's actually, in this case, some things that are in common. If you notice, x to the fifth, x to the fourth, and x to the 10th. All three of those terms have some power of x in common. So since it's being divided, we can divide out whichever one is the smallest. So this x to the fourth actually goes away. This fifth power, if you take away 4 of them, becomes a first, and this 10th would become a sixth power. If I write down what's left over, this would be 3x e to the 3x minus 5e to the 3x all over x to the sixth. And while this is a perfectly acceptable answer, the only other thing you might see some people do is, since both terms share an e in common, I could factor the e to the 3x out and leave a 3x minus 5 on top. Just in case they want you to put it in the fully factored form, you would have to do one extra step. I don't think you have to, but just in case, that's there for you to refer back to when you're doing your homework and such. All right, so let's do some combo rules. Like I said, trying to throw every kind of e derivative I can think of. What is the derivative of f of x equals e to the x plus x cubed minus x e to the x? So as I work from left to right here, the first few terms are just being added and subtracted, so you can take their derivatives separately. The derivative of e to the x is just e to the x. The derivative of x cubed is going to be 3x squared, and then minus, and here's where you've got to be careful. Since this x and this e to the x are being multiplied, you have to do the product rule here. So I'm going to let the x be my f function. I'm going to let e to the x be my g, and I'm going to apply the product rule just to those two terms. So let me put the product rule back up here. Now, since there is a minus in front of this entire product rule, I'm going to put the product rule inside parentheses because I'll have to apply that negative once I'm done. All right, so product rule. I'm going to take my f function, which is x, times the derivative of g, which is just e to the x, plus g, which is e to the x, times the derivative of f, which is just 1, and then I'll close my parentheses. All right, if I distribute this negative to both of these terms, this becomes e to the x plus 3x squared oops, sorry, that's bad handwriting right there. Let me clean that up so it doesn't throw anybody off. Sorry, here's my eraser. So that would be minus x e to the x. This times 1 doesn't do anything, so I'll still apply the negative. So that's minus e to the x. And we actually get kind of lucky here that this e to the x and this e to the x cancel and leave us with a final derivative of 3x squared minus x e to the x. So nothing really new from the last couple problems, but I wanted to try to mix in a few things at once and an example where some stuff will cancel in the final answer. All right, and then last thing I want to do for this video, now that we've learned a new derivative rule, we're going to do the equation of a tangent line to wrap up section 2.2. So I would like you to find the equation of the tangent line to the graph of g of x equals 2e to the negative 4x at 0, 2. Hopefully by this point of watching all these videos, you're starting to get the idea that tangent lines are very important. So it's the same strategy. The big difference is how you take the derivative of each function. So let's go through this process again. To find the equation of a tangent line, step number one is you have to find the derivative of your function. So we're going to find g prime of x. Remember with the e, you're going to take the derivative of your power, which is negative 4, and bring that to the front. Since there is a 2 already there, you need to multiply those two numbers together. So negative 4 times 2 would give you a negative 8, and then you bring down the exponential function. To find the slope of the tangent line, remember you have x is 0 and y is 2. You take your x value and you plug that into your derivative to find the slope. So the slope of your tangent line would be negative 8e to the negative 4 times 0. Well, this becomes negative 8 times e to the 0 when I simplify that. E to the 0 is just going to be 1, so your slope actually ends up being negative 8 here. Now I can use this slope and the original point that I gave you, and we can use our point slope formula to write the equation of a tangent line. So this would end up being y minus your y value, which is 2, equals your slope of negative 8 times x minus your x value, which is 0. Well, multiplying the right-hand side by negative 8, you should just end up with y minus 2 equals negative 8x. And if you add the 2 to the other side, you should get a final answer of y equals negative 8x plus 2. And that is the equation of the tangent line. Same techniques, but how you find the derivative is what's different about all these problems we've seen to the end of each section. That ends the video for section 2.2. That's how you take the derivative of an e function. In the next video, we will talk about how to take the derivative of a natural log function, which is a little bit more difficult, but still very similar to how you did e's.